Suppose we have a reaction that's in the equilibrium state, so the rate of reaction in both directions is equal. And we can place a stress on the system at equilibrium by changing the concentration of the reactants or products. And according to Chatelier's principle, the system responds to relieve the stress. So in this example, if we increase the concentration of one of the reactants, then the reaction shifts to the right to use up that added substance. And if we decrease the concentration of a reactant, then the reaction shifts in a direction to create that removed substance, which is to the left, or in the direction of the reverse reaction. And similarly, if we increase the concentration of a product, the reaction shifts to the left to consume the additional product. And if the concentration of the product is decreased, then the reaction shifts to the right to create more product. Another way we can stress a reaction that's at equilibrium is by increasing or decreasing the temperature. So if we have an exothermic reaction, we add heat to the right, thereby assuming it as a product, and therefore an increase in temperature will increase the product, and the reaction shifts away from the increased energy, which is to the left. Now in addition, because a change in temperature changes the reaction kinetics, because it affects the rate constant, then the equilibrium constant is going to be affected by a change in temperature. So because here the reaction shifted to the left, then the concentration of the product would decrease, and the concentration of the reactants would increase. And therefore an increase in temperature would result in a decrease in the magnitude of the equilibrium constant. And conversely, if we decrease the temperature, then the reaction shifts to the right to create more energy. And therefore, the concentration of the reactants will decrease, and that of the products would increase. So that would result in an increase of the magnitude of the equilibrium constant. And in the case of an endothermic reaction, we will treat the heat being added as a reactant, and I'll leave it for you to think about and verify that the shifts in the reaction will be in the opposite direction to the exothermic reaction. And similarly, the magnitude of the equilibrium constant would increase with an increase in temperature and decrease with a decrease in temperature for an endothermic reaction. Another way we can stress a reaction at equilibrium is by changing the pressure of the system. Say if we increase the pressure on the gases by decreasing the volume of the container, then the partial pressures of all the gases would increase. And because there's more moles of reactants than products in this case, the reaction would shift to the right to relieve the stress, because the partial pressures of the reactants would be higher. Now if we decrease the pressure on the system by increasing the volume of the container, then the partial pressures of the gases would decrease. And therefore, because there's more moles of reactants on the left than there are of products, then the reaction shifts to the left to relieve the stress according to Chatelier's principle. So effectively this reduces the partial pressure of the product and increases the partial pressures of the reactants. Now we can also increase the pressure by adding an inert gas while keeping the volume constant. So in this case, the inert gas does not react with the other gases and won't increase their partial pressures. So therefore, the inert gas will not affect the equilibrium constant, and therefore there's no stress on this reaction which is at equilibrium, and no shift in the reaction occurs. So only the total pressure of the gases changes due to the addition of helium, for example, which is an inert gas, which is the sum of the partial pressures of the gases. But the partial pressures of these gases does not increase. And similarly, when we have an inert gas and we decrease the pressure at constant volume, then no shift in the reaction occurs for the same reason. We can stress an aqueous solution by diluting it with water. So if we increase the volume of the solvent, then that effectively decreases the concentrations of the reactants and products. So if we have more products, then the reaction shifts to the right in this case to create more products, because there's more aqueous species on the right that lose concentration. Now if we decrease the volume of a solvent, so for example by evaporating water, then we're increasing the concentrations of the reactants and products. And therefore the reaction shifts to the left in this case, towards the reactants, where there's less aqueous species. An experiment is conducted where sodium chloride is added to the following solution, which is purple at equilibrium. Will the color of the solution appear closer to blue or pink? So at equilibrium, the cobalt tetrachloride species is blue, and the other cobalt complex is pink. And by adding sodium chloride in an aqueous solution, this dissolves into sodium and chlorine ions, and thereby increases the concentration of the chlorine ions in the solution. So therefore the reaction shifts to the left to relieve the stress due to the increase in concentration, and will thereby create more cobalt tetrachloride, and the solution will appear closer to blue than pink.